Welcome everyone to ARM Matters Summit today. ARM technology is defining the future of computing. ARM's energy-efficient processor designs and software platforms enable advanced computing. As you may know, ARM IP powers 55% of consumer devices and covers diverse use cases. The IoT runs on ARM. According to the market research company ABI Research, more than 5.5 billion smart home Matter-compliant devices will ship between 2022 and 2030. Matter is a unifying standard to ensure reliable and secure connectivity to create more connections between more objects, simplifies development for manufacturers, and increases compatibility for consumers. To help the industry unleash the innovation and grasp the huge opportunity for the IoT, ARM invites CSA, the Connectivity Standards Alliance, the leading SIP companies including MediaTek, Silicon Labs, and Rafael Micro, D-Link, the global leader in designing the developing networking and connectivity products, and Allion Labs, the leading company who provides diverse services to assist you in product design consultation, specification consulting, product certification consulting, etc., to participate in the webinar today. In today's webinar agenda, we will take a deep dive into Matter, including Matter technical overview, ARM total solutions for IoT, ARM virtual hardware, Project Centauri, Project Cassini, and the applications and the certification for Matter products. Please stay until the end of the game to gain the valuable insights to develop your IoT and Matter products. And now the summit will begin. First of all, allow me to introduce Mr. Laurence Bryant, VP of Segment Marketing of IoT Lab of ARM.
Hello. Thank you for joining us today. I'm Laurence Bryant, VP of Segment Strategy in the IoT line of business at ARM.
Next, I would like to introduce Mr. Parag, the Director of Segment Marketing of IoT Lab of ARM.
Hello, everyone. My name is Parag Biraka, and I am the Director of Segment Marketing in the IoT line of business at ARM.
Thank you, Mr. Parag Biraka. And next, I would like to introduce Mr. Chris Lepre, the Head of Technology of CSA.
Hello, my name is Chris Lepre, and I'm the Head of Technology at the Connectivity Standards Alliance, and I'm here to talk to you about the Alliance and Matter in particular.
Thank you, Chris. Now I would like to welcome Mr. Allen Huang, the Senior Go-to-Market Manager of IoT Lab of ARM.
Hello everyone, I'm Allen from ARM.
Thank you, Mr. Allen Huang. And next, I would like to introduce Mr. Blade Lin, the Staff FAE of ARM. Welcome, Blade.
Hello everyone, I'm Blade Lin, and I'm Taiwan FAE.
Thank you. And now I would like to welcome Mr. Laurence Bryant to give us an opening speech. Welcome, Bryant.
I'm super excited to be here today to kick off the ARM Matter Summit. It is great to see so many attendees from multiple regions. Thank you everyone for joining this webinar and welcome. Today, we are going to discuss all about Matter, starting with the size of the opportunity in front of us. According to ABI Research, more than 5.5 billion smart home Matter compliant devices will ship between 2022 and 2030. Matter is a unifying standard to ensure reliable and secure connectivity, simplifying development and increasing compatibility of devices. In an important milestone on this journey, the Connectivity Standards Alliance, with which ARM has collaborated for years, just released the Matter 1.0 standard and a certification program in October of 2022. As we all know, the IoT runs on ARM. Matter-compliant devices will also run on ARM. With Matter, the Alliance aims to create a universal IoT standard focused at the application layer, with the goal of simplifying development for manufacturers, providing consumers with the interoperability of diverse IoT devices that they desire. Through our close collaboration with our ecosystem partners, we can ensure there will be further innovative solutions developed. This collaboration involves many factors: the delivery of a family of ARM IP, close engagements with silicon vendors, tools vendors, software services, and the use of security frameworks to best address the diverse nature of IoT applications. As such, ARM is the platform on which Matter-compliant devices will emerge first and then accelerate in adoption. ARM is working closely with the members of the Connectivity Standards Alliance to ensure that the ARM ecosystem is ready to support OEMs and other product developers in building these devices. This includes a current ongoing project with the Matter CI team to explore the integration of ARM virtual hardware, our modeling technology, into the continuous integration flows of the Matter CI/CD frame infrastructure. Through this practice, ARM virtual hardware can ensure that product developers can instantly access a scalable virtual test environment of ARM-based computing platforms for IoT. To help the industry unleash the innovation in IoT today, along with ARM, we have Connectivity Standards Alliance silicon partners, including MediaTek, Silicon Labs, and Rafael Micro, and D-Link, the leading company in designing networking and connectivity products, along with Allion Labs, the company that has been providing Matter certifications. All of them are here to share their insights about the market, discuss various technologies related to the development of Matter. They will also share how every one of you can develop, secure, certify, and make applications on ARM to capture the huge opportunities in IoT with Matter. Lastly, I would like to thank you again for the participation in the webinar. Please enjoy the various sessions from us and our ecosystem partners. Thank you.
Thank you, Laurence. Up next is Mr. Parag Biraka to give us the presentation.
Today, I'm here to talk to you all about market trends and future opportunities with Matter. Matter is a protocol to connect compatible devices with devices and systems with one another. Smart home devices should be secure, reliable, and seamless to use, and that's what Matter provides. The first specification of Matter was released last year in 2022, and many companies have announced support for end products and silicon with support for the protocol. With that background, let's get started and talk more about future opportunities with Matter. Now, having looked at some high-level trends, let's get into some specifics here. IDC estimates that there will be roughly more than 3 billion smart home devices shipped this year alone. And in the year 2026, this number is going to grow by 50% to 4.5 billion devices. And this number is going to need to grow over time. The increase in these devices continues to be across a wide variety of verticals. And here are a few to name. Smart appliances. Smart appliances include devices such as refrigerators, toasters, ovens, coffee makers, etc. We've already seen refrigerators with huge screens where a lot of cooks are trying to enable their own recipes and have YouTube videos to cook. Comfort and lighting. Light bulbs, fans, and plug sockets come in this category. There are quite a few number of devices available with smartness in these devices already. Then you have home entertainment. This is where devices such as smart speakers, smart displays come in. Then you have security, which is one of my favorites. You have consumer home cameras installed in your homes, along with security systems for alarms, and also many sensors on your doors, windows, etc. Then you have control and connectivity. Here you can have devices such as garage door openers, door locks, and even your wireless routers in your home, which act as home gateways. Then you have energy management. This is where you have devices such as thermostats, water heaters, and many other energy management devices. Almost every electronic device in your home will be connected in the future, thus really enhancing the user experience. Now, there's a term that you might have heard about called ambient computing. This is where we think the whole market is going to trend towards adoption of this new technology called ambient computing. Ambient computing refers to always-on hardware and software technologies that allow users to consume digital content and services by interacting with their surroundings. We are still at the beginning of the curve, but we predict that over the next decade, there will be a fundamental shift in how we consume these devices. Right now, we have many ecosystems and many devices, kind of walled gardens in the ecosystem. We expect these devices will become interoperable and really enable the next wave of computing in the IoT, which we call ambient computing. With that, we have looked at the market trends. Now let's talk more about the future opportunities with Matter itself. In order to understand the opportunity ahead of us, I think it's also important to understand what all does Matter enable. So at a very high level, this is how we see what Matter enables. The first and foremost is interoperability. Second, simplicity. Third, differentiation. Even though they are standardizing, there is still space for differentiation. And lastly, technology across different verticals such as silicon, software, and even services. With that high-level information, let's go deeper into each of these trends and then figure out what the opportunities are. So let's talk about interoperability, which is the first and foremost element that Matter has really brought together. Using embedded sensors and smart devices, the idea is to really have a physical map of the world around it and to seamlessly interact with other devices. As a consumer, one can buy devices from different vendors because of their unique requirements, taste, and many other reasons. Now, these new devices should seamlessly work with devices that are already existing in your house and also future devices that you might buy. There are so many use cases that should just seamlessly work with the emergence of Matter. Imagine yourself coming in through your car and your garage door automatically opens. Once you park your car, your door lock automatically opens. Then you enter your home and the appropriate temperature settings are set by your thermostat. The appropriate lights and fans are start on depending on the time of the day and the temperature inside, to really bring in the comfort that you need, all with just technology. Now, this is feasible even currently with applications from different vendors. But imagine all of this working together seamlessly using one application on your phone. This is what Matter will really enable. So that's why we think there is immense opportunity with respect to interoperability and Matter in terms of development, services, and many, many other things. Now, what we really expect Matter to bring in is a use case that I can talk about. Imagine you have home cameras in your home from one vendor, such as say Ring, which is owned by Amazon. And then you have a smart display hub from Nest, which is owned by Google. And someone enters or shows up at your front door, and you would like to see who is at the front door through the Nest display hub. So if at some point in the future, the Ring cameras live stream can be viewed on a Nest display hub, I think this is what Matter really brings in. And you can see the potential that Matter brings in because of the interoperability angle. So the first one, interoperability, I think we kind of walked through the opportunity that exists there. Now let's move to the second one. Matter actually enables simplicity to the consumers quite a lot, actually. Now let's look at the picture here. In the past, consumers would usually buy devices from different vendors, and they would all install them in their respective homes and mostly download their own applications provided by the vendor on their phone or tablet. But the consumer had to worry about ensuring that they are properly connected, they have security properly configured, and many of that. And at the same time, it was very unlikely that these two devices that the consumer bought could work together, thus complicating consumer by having two different applications to control two different devices. Now with Matter, as we talked about the interoperability, now Matter also brings in what we call the simplicity at the expense of many other development that happens across silicon services, device management, and many other ways. Let's look at the present and the future with Matter. You can see here we have a device, IoT device, which is Matter enabled. First and foremost, it enables a service. It enables provision of a value-add service. It is going to be secure. Then it's going to use modern protocols. It's going to be manageable. And it also will have the capability to either connect to a public cloud or a private cloud. And then it can actually also be managed by different services so that they're ensuring that all of the updates are delivered to the devices over time whenever there are security hacks or anything like that. Now, let's talk one of the specific things related to use cases. You can see here that this device also can run machine learning. With machine learning, it further enables simplicity to the consumer because here many companies can use a lot of machine learning models catered to specific consumers. So the opportunity here is there from developers' point of view, from silicon companies' point of view, from end OEM's point of view across all these services or technologies. And at this time, you're providing simplicity to the end consumer. So this is really one of the key vectors that Matter brings in. And we are also super excited to be contributing to Matter in some of the aspects of what we are showing here. Now, the third vector that Matter really enables is convergence, but enabling differentiation. As you can see here in the picture, different silicon companies will continue to have their own software development kits at the lowest layer because they might have unique protocols, that unique features that they would like to differentiate with their own silicon. This could be better battery life, better connectivity, better reliability, better security, beyond what Matter would provide. And then when you move up, you can see that Matter really standardizes some of the network protocols such as Wi-Fi, Thread, BLE, Ethernet. And there is future opportunity here in defining new protocols for a new class of devices. Then if you keep going up, you have standards across IPv6, TCP, UDP, and then finally the layer 3 stack, which is Matter itself. But then on top, you have different devices and different services and different applications, which are all enabling differentiation, even though Matter is bringing together convergence. I'll give a simple example. A light bulb from GE is going to be very different than a light bulb from IKEA. Similarly, we expect a wide variety of devices which continue to provide their own level of differentiation, even though they're adopting Matter as a standard. And we already see this with many devices from large OEMs like Amazon, Google, Apple, and many other companies. The last one that Matter enables is newer technologies and really the development of a huge, huge ecosystem. Now, let us start with the technology itself. There is definitely increasing needs in technology across multiple vectors such as compute, security, machine learning, and even connectivity. With respect to compute, now since Matter has different layers, we do expect that the compute needs need to grow in order to enable interoperability. Along with compute, we expect the needs for memory to grow. And at the same time, with more compute and more memory, we do expect complications and ensuring that the proper security protocols are enabled at these end devices. Then we come to machine learning. Machine learning is going to be a game changer in IoT. And smart home devices will be one of the key verticals that will enable machine learning. Just imagine having the capability to detect how many people are at your home in a party so that you could plan better next time. Or even have presence detection to not just have your thermostat running unnecessarily. All of this is possible with machine learning. Then we have connectivity. There are already a lot of standards enabling connectivity, which Matter actually uses, as you have seen. But there is future opportunity in enabling new standards to enhance the consumer experience. A lot of smartphones are using technologies such as ultra-wideband, GPS, etc., to really enhance the user experience. At some point, we do expect similar technologies to show up in these smart home devices to further enhance the user experience. Now, in order to have interoperability and work seamlessly, it is not just the technology that is important. We also have different other verticals, such as developer ecosystem, where there could be new frameworks developed in order to ensure there are easy deployment of home solutions. At the same time, whenever there are developer enablement, there is always tool flows, which one has to provide to simplify the developer experience. This could be related to CI/CD, machine learning, MLOps, DevOps, and many other flows. And we are already seeing huge number of opportunities in front of us. And there are quite a few number of startups who are also embracing these newer trends. The third pillar in the technology stream is software solutions. Software solutions, I would say, can be categorized as solutions related to remote monitoring of your devices, connection control, ensuring that they are reliable, secure, and whenever something goes down, you're immediately notified so that you can take appropriate action. Then the last pillar is really services. Because of the number of devices in your home, it provides a lot of opportunity to enable new services related to energy management, home automation, security management, all remotely as well. So this can enable completely new class of services catered towards different types of consumers, thus enabling new business models as well. This is why we at Arm are also extremely excited to be participating in Matter along with many other companies. Now, the Matter ecosystem is already accelerating at a rapid pace. You can see just a few companies here listed, and this is just a small set of logos that we have captured. You can see that it's really a global collaboration and leadership from all the companies in the world. There are around 450 companies that are engaged in 36 countries, and with over 3,500 members participating on a daily basis. And just in 2021, there were 150 new member companies. So there are more and more companies in the world. We expect that more and more companies will join the Matter consortium and continue to provide many, many devices to consumers. Now, Arm has been an active member in the Matter community for many years. Arm also has a wide variety of devices that are helping adopt Matter in a much faster pace. We have our bread and butter Cortex-A, Cortex-M class of CPUs. We have Arm Corestone, which simplifies silicon development and reduces time to market by providing pre-built example verified subsystems for any new or even existing silicon partners. Then we also have many tools such as Arm Virtual Hardware, Arm IP Explorer, and Arm Socrates tools, which will simplify not only the SoC development process, but also the software and embedded development process. And then we contribute quite a few number of things to open source community. This is where we have our OpenCSS packs and OpenCSS CDI to kind of provide and accelerate the adoption of ecosystem with standardization. And then we have our development studios and ARM Kyle for further accelerating the technology through our tools. So, to summarize, there is immense opportunity ahead of us for the entire ecosystem to embrace advancements in smart home. Smart home will continue to drive various emerging trends, which includes technologies, developers, ecosystem, and even new services, thus benefiting several companies. Matter will continue to gain adoption beyond the smart home in even commercial establishments, industrial applications, retail, etc. in the future. And ARM continues to be in the center of driving the Matter in enabled ecosystem. Finally, the revolution that's upon us in IoT is all about the economy itself. From smart cities to industrial automation to smart homes that we just talked about, we believe that IoT will transform every aspect of our lives and enrich all the participants in the value chain, all based on ARM. That's why we say IoT runs on ARM. Thank you.
Thank you, Parag. Next, please welcome Chris, the head of technology of CSA staff FAE of ARM, to give you an overall introduction of Matter.
And I'm here to talk to you about the Alliance and Matter in particular. The Connectivity Standards Alliance is here to resolve all of the problems that we see in the Internet of Things. We feel that the Internet of Things should positively transform the way we live, work, and play, and reduce the complexity, remove the challenges of accessibility and trust that have held back progress and have reduced the market for the Internet of Things. Since 2002, the Connectivity Standards Alliance has been unraveling these challenges. We've been trying to simplify the complexities of the market and increase IoT adoption. We've been doing that by promoting universal open standards that collectively enable all objects to securely connect and interact with each other and with humans. The way we've done that over the years is, in the beginning, we are still responsible and were responsible for Zigbee. So when 802.15.4 was first announced in the 2000-2001 timeframe, we immediately saw a possibility for a mesh network enabled on top of that, and then the Zigbee Alliance was formed around 2003 to put that self-healing true mesh network in place that has indeed revolutionized the Internet of Things, particularly in the smart home. After that, our focus was a few years later on smart energy. Basically, all the electric meters and electricity companies, gas meters, came here to use that Zigbee mesh networking technology to build a smart energy specification that would enable pricing indications and other methods to reduce the use of electricity and further help utilities interact with humans to save energy and money. Later on, we had a focus on green power, which is batteryless technology. It was enabled right inside light switches. So no batteries were needed, and that those light switches and other technologies could interact directly with the mesh network that we've been talking about. In 2 or 3 years later, we came out with our third version of the Zigbee Pro Stack, and we call that Zigbee 3.0. It enabled lots of new security features and other network topologies on top of Zigbee as well. Then fast forward to 2019, that was when we announced Matter, a totally new technology. In some ways, sort of Moore's law that was feeding into the reduction of price of silicon enabled a new technology. Zigbee was not IP-based, but that Matter could be IP-based. And it is a new technology that could be entirely, could revolutionize the world, again, from adoption, but we'll talk about that in a little bit. And we're also going to be announcing soon R23 version of Zigbee Pro with some new features there as well. So back to the CSA, you see on the left here, all of our board members. We have a global leadership, companies from all over the world take part in our board of directors. And, now after being Zigbee focused for 15 or 16 years, we are now a multi-standards group enabling collaboration across many areas of IoT, hoping to accelerate the market, again, with that adoption promise and an open path to adoption. So to dig a little bit deeper into the Connectivity Standards Alliance and other things that we're working on, I've already mentioned Matter, and I'll definitely go into that in more detail. I've also mentioned the Zigbee working group that's been working on Zigbee for 20 years now. Both of those have the same data model. So in order to govern that data model, we formed a data model working group. We want to make sure that we don't have multiple definitions of what a light bulb is or what a door lock is. The unlock command should always be the same. So we have a data model group sort of in the middle of those two groups. And since then, we've also formed an access control working group. That group is working on a universal credential and technology stack that could then operate on multiple radios. Most of the radios that are used in door locks and other access control technologies require their own technology stack and their own credential. And that was seen as further division in a roadblock to adoption of Internet of Things. So again, that was a problem that we would want to solve. So for a little over 2 years now, we've been working on access control as well, and we'll have more about that in the coming year. More recently, about a year ago, we've announced a product security working group. Again, interoperability was one of the major problems stopping connected devices. Product security was the next major hurdle, and trust in the devices that people are buying into their homes. If you look around the world, there are about 60 to 70 different countries or regions that each have different regulations for how to what the level of security that different products must have to be sold in those regions. That's obviously extremely confusing for manufacturers to be able to sell in all of those different regions. The product security working group is looking to put some type of an umbrella specification on top of that, and in particular, a certification program on top of that that will enable a manufacturer to build a product securely and make sure that that can be sold around the world. In addition to those 5 working groups, we have different regional interest groups, a member group in China and an EU interest group based in Europe, as well as industry stakeholder groups that allow the different industries that we see here on the right, the devices and manufacturers in purple, which you see represents the most of our membership, ecosystems and platforms, retailers and channels, and silicon and software integrators and design. Each of those 4 areas have their own industry stakeholder groups where we exchange information with them based on those multiple different industries. And then further to the right, you see our division by region, where it is quite evenly divided between Asia, including China, and then Europe is slightly larger than our other regions, and then the Americas is an equal balance as well. So coming back to Matter, what is Matter? I mentioned before, is it really strongly trying to figure out what the interoperability problem is? What are the world, what was it that was causing the major ecosystems to have these walled gardens and not be able to have a single standard across them? Interoperability was the problem that we were trying to solve. But in addition to that, we laid out three other target areas for us. Of course, it has to be simple to use. Can't be something that's too complex. It has to really just be a pull the tab and then boom, your device is on your network. It has to be reliable. Can't be something where you're pushing the button on the wall and then a couple of seconds later, the light hasn't gone on yet. It has to be reliable and fast. And last, but certainly not least, and I'm going to talk a lot more about this on a future slide, it has to be secure. When we first started talking about this, again, interoperability was what got us into the room, but security was the first word on all of our lips. We were really needed to make sure that it was highly, highly secure. And as I said, we'll have more to talk about on that in a subsequent slide. So again, simple, interoperable, reliable, and secure. It has, what we needed to do from the get-go was to unify the industry with a single standard. Again, that comes from this adoption promise. When we first started, we had major players in the room, and we needed to make sure we kept them along with us for the whole entire ride, and that at the end, they were committed just as much as they were in the beginning to building products on top of this. It had to be simple, a simple, consistent flow of pairing every single time. There has to be a barcode or something else that works every single time, such that you don't have to do different things for different ecosystems or different manufacturers. And again, I talked about security, but we'll talk more about that later. So on the manufacturing side, we had to set out and make sure that we provided everything to make things really, really easy for manufacturers as well. So of course, it had to have a specification as part of the certification program. We have a complete SDK toolkit, all the test scripts and tools. It's very, very quick to grab what's in the SDK, look at what's in the spec, and then build out your products, and then be able to take them to a certification program really quickly. And then also have support for the developer community here within the members of the Alliance. And on the right-hand side, you see a number of our earliest companies that were committed to building Matter products. So let's delve a little bit deeper into what we have here. What Matter is, as I mentioned this before, it is IP-based. So for a home network, what that means is at the bottom layer, you have Wi-Fi and Thread. We have Bluetooth, low energy for pairing from a phone in particular. And of course, it supports Ethernet or power over Ethernet. There is, of course, support, flexibility to support future networking layers, but Matter today includes just those 4 networking layers for today. We're built on top of IPv6 at the bottom in terms of the networking. And then, of course, it's TCP and UDP. And then all of what I've been calling Matter lives above that. We don't delve below that layer. It is mostly Wi-Fi and Thread that are below that. And then below, at the bottom of this picture here, you do see the target categories that we are focused on. That includes HVAC controls, mostly thermostats or in-wall or in-window cooling, window coverings and shades, safety and security sensors, that's mostly do-it-yourself security alarms, motion sensors and contact sensors. Of course, the standard lighting and electrical, light switches, light bulbs, smart plugs, door locks. One thing that we've added in Matter is support for media devices, or I should say better support for media devices. And that's an interesting category for us as well. And then because it's IP, there's a number of categories that need to be added to that. Access points and controllers are in that category. And then bridges are an extremely important category for backwards compatibility. Other devices that are in your home today can be connected into a Matter network by bridges. And then in terms of features, we have listed on the right, for the manufacturer perspective, it is a common application layer that increases interoperability and makes things really easy for you to build products, build all the different types of products you have, and then make sure that those will work with multiple ecosystems. We've already talked about IP. I'll mention security again later. So the last thing I'll mention here is that it's particularly low overhead. It is IP based, so it's not as small overhead as some non-IP based things. We do need to handle IP packets, but for that, it is still an extremely small footprint for these devices. So here's a slide I've been talking about in terms of security. And we do have a white paper on this as well that you can find on our website, csaiot.org, that goes into much more detail than this. It actually talks about 10 different categories, but I'll just highlight a few of them right here. In particular, and I like to go from the bottom up, but agile is one that is extremely important for us. We have looked at a number of threats that we're concerned with, and for each of those threats, they are time-based. The threats that we're seeing today are going to be different than what we're seeing in the future. So we needed to make sure that we were agile such that we could quickly flip in the future. Today, for example, AES 128 is the standard, and it's more than sufficient. But in the future, we know that won't be the case. On the other hand, we know that silicon, for the more expensive, there's no silicon accelerators for better encryption on that side, but that's also catching up. So when those two things have balanced better, we can very easily switch to AES 256 or 512 or 1024 or whatever it does, whatever it is that makes sense at that point in time. Another piece I like to pull out here is easy. It has to be easy to use in particular for consumers, but also for manufacturers. It can't be lots and lots of hoops for them to jump through to hit that security bar. It has to basically be built in. And if you see in our SDK, the security that we have there is turned on by default. There's no way to really turn it off. So it's really easy to use. It just does all the security things you need for you. So it's very easy for the manufacturer. And on the consumer side, it's the same way. I'm pulling up my phone, I'm scanning a barcode, and then that device is on my network, ready to communicate. There's nothing extra that I need to do for it to be security. So easy is something that we've always thought was extremely important, because if it's not easy, we know consumers and manufacturers will just turn it off because people don't like to do things that are hard. And then the last one I'll mention, which is probably the most important, is that it's strong. It's the cryptographic suite behind it. The certificates that are required for it are state of the art. I'm going to say SSL grade. It's not SSL, but it's the same types of encryption that are there, the same types of cryptographic suites that are there. So extremely strong and state of the art for the internet today, not just the internet of things today, but for the internet today. And like I said, there's a white paper that we have available on our website that has lots and lots more detail there. So what are we working on in the future? There's a number of future plans that we have. 1.0 has launched with all these things you see here. That was launched in October. What we're working on next, the top two here, you see appliances and robot vacuums. Those are slated for our spring release. We'll need to obviously complete that release to make sure that those device types are what we call certifiable, have all the test cases built and have manufacturers ready to implement them. But right now we are on track to do that. Cameras and doorbell cameras are on a slightly longer trajectory. I'm hoping that those are available in a fall release that we have coming out later in 2023. We have lots and lots of use cases that we're working on in terms of energy management. EV charging is one that's mentioned here, but lots of pricing indications, water heaters, isolation switches. There's about 10 different focus areas that we have for the energy management space. That's all sitting underneath the Matter umbrella that we're really excited about as well, to help consumers save energy, save money, and that's really important for lots of the consumers that have reached out to us recently. Another focus area for us is on the IP side of things we talked about. So access points, if an access point is the consumer's only interaction point to the internet, what is the right interface for that? I think a set-top box would look pretty similar to that, potentially with a slightly richer interface through the TV. And then border routers fit into the same thing. How does Thread interact with the larger network, and how can consumers interact with that? And I will throw out just some teasers. We have started to look into some other areas like health and wellness and how that might interact in the future with a Matter network. But definitely keep an eye on this spot for us at csaiot.org, and we'll have more to announce on that in the coming year or so. So to sort of summarize in a different view, We've talked a lot about consumers. Matter has to provide a single, consistent setup experience. We haven't talked much about multi-admin, or actually I haven't mentioned it at all. I apologize. But what that is it enables a single device to talk to multiple ecosystems. And we have more information on that on our website as well. But that allows consumers to use multiple ecosystems. And again, with that consistent setup experience, simplifies things for consumers and allows manufacturers to then develop more and more experiences on top of that. We've talked a lot about developers. It's really easy for them to develop something using our SDK and ensure that that works for all of the different ecosystems that manufacturer wants to interact with. We've talked about security by design. It's built in at every layer. It's very easy to use. The community of support that we have here within the Alliance membership, that's another piece that developers lean on pretty regularly. Retailers, we haven't really talked about this much, but it simplifies the purchasing experience, which therefore minimizes returns. Today, we have this problem in the retail experience where I just don't know if this device is going to work with the ecosystems I have at home. And it's the retailers that take the brunt of that cost by dealing with the returns that will happen if I do bring a device home and it just doesn't work. Matter will simplify that and reduce those returns. And lastly, for commercials and builders, there's lots of desire for builders to put smart homes into, to put smart technology into the homes that they're building. And Matter also enables experiences for them. And I'll also mention multi-dwelling units and commercial building as areas of interest for us to be looking at in the future as well. So that's the bulk of what I wanted to talk about in terms of Matter. Certainly reach out to us here if you have any questions. If you do wish to join, please come to csa-iot.org. There's lots of links there, particularly in the upper right. There's a Join Us link, and you can see all the information there, and then reach out to join the Alliance. And with that, I'd like to thank ARM for having us here to talk about Matter and the Connectivity Standards Alliance, and definitely thank all of you for listening, and we'll talk to you soon. Okay, thank you. Bye-bye.
Thank you, Chris. And next, please help me to welcome Mr. Alan Huang, the Senior GTM Manager of IoT Lab of ARM, to give us a presentation entitled ARM Total Solutions for IoT with Matter Support.
Hi everyone, nice to meet you virtually and welcome to join ARM webinar. I'm Alan Huang, ARM Go-to-Market Manager, and great to share ARM's total solution for IoT, as well as our support to Matter. We'll use the chance to share what we get from developers for IoT development. So first, let's see what's the trend in the IoT. Over the last few years, what we've seen a very clear shift, a shift which is still accelerating of more intelligence at the embedded edge. This is mainly driven primarily by two factors. The first, of course, is increased compute capability at the embedded edge. So this will continue to enable more complex functionality on devices that were previously resource constrained. The second factor is the volume of connected devices is continue to be increased. So as we are talking about Matter mainly today, which are most focused on the connected device equipment part, for sure, that Matter is mainly used in smart home at the first, but it will continue to expand in different fields and application scenarios, such as smart city or even industrial fields. Provide not only our IP, just like Cortex-A, Cortex-R, and the Cortex-M with the MPU, but also build a more friendly ecosystem to ensure our support for Matter, even in the edge or data centers. Total solution for IoT is a solution-based approach to IoT design, which is made up with three key elements. First, ARM custom. These are pre-integrated, pre-validated subsystems designed for specific use cases. For silicon partners, ARM custom massively accelerate the time to tape out and the production. And the next is ARM virtual hardware. ARM virtual hardware creates a virtual platform based on the custom designs and make it available in the cloud. This one is enables modern cloud-based developments, including things like continuous integrations without the need to set up and maintain a hardware farm. It can easily scale to thousands of devices, and because ARM virtual hardware is available at the same time as the underlying IP and the custom design, developers and OEMs can start work long before silicon is available. And the third, Project Centauri, an initiative that brings together with the standards, security, and the ecosystems to enable software reuse and leverage. So Project Centauri scales IoT software innovation by enabling developers to prioritize their investments and increase and speed up their investments across many more devices. So no matter custom, ARM virtual hardware, or virtual Centauri, we are all make sure the matter support and capabilities. So allow me to introduce more in coming slides. ARM custom subsystem is the foundation of our total solutions. These proven subsystems bring together all the elements our hardware partners need to be able to get their products to tape out faster. All they need to do is focus on aiding their own differentiations. It's why ARM custom has been used to accelerate time to tape out in over 200 designs to date. We keep to invest our roadmap with matter-related devices support, including vision, voice, sensors, and edge gateway related applications. By providing everything from pre-integrated, pre-verified hardware subsystems to references software and modern software development flows, ARM Total Solution for IoT enables our ecosystem to accelerate the time to market, lower investment cost, and focus on what really matters, innovation and differentiations. Our first total solution for IoT was keyword spotting and based on the custom 300. Today, we are adding more and more custom solutions, just like we have the custom 310 and the custom 1000. With all of our total solutions, we work hard to make sure we can providing all the essential integrated for completed solutions, by maintaining enough freedoms and the flexibility to allow developers to get creative. So let's take a close look at what's the new total solutions in more details. IoT and embedded is an incredibly diverse space. There will be hundreds of chips designed to serve thousands of unique markets and design points, and they will cover a range of performance and workload requirements. Stepping back for a second, you can now see how we've begun to scale ARM core stone to address all of these different applications. We are unleashing the potential of IoT at scale by creating pre-integrated, pre-verified hardware subsystems that able to accelerate the time to market for things as diverse as smart light at the one hand, and the other way through to smart camera and the IoT gateways at the others. The investments we are making in new IP, just like Cortex-A, Cortex-R, and the M with the MPU, and the all subsystem core stone designs. The real magic of our total solution approach is that we are investing at least as much in the software ecosystems. So let's jump into discuss what we have supported in the ecosystem. So in September 2021, as part of our first ARM total solution, we launched ARM Virtual Hardware as a cloud-based offering. The first ARM Virtual Hardware target was a virtual replicate of the Cortex M55-based Core Stone 300 design. It was made available on AWS as an Amazon Machine Image, or we call it AMI. Even though there wasn't any M55 silicon in production, we know our most valuable partner like Lab 126 and Google were already using virtual hardware to enable software development without the need for physical silicon. Their developers didn't have to worry about jumpers, cables, and availability of hardware in order to write software for IoT devices. They could accelerate time to market by developing for silicon, which haven't even been tapped out yet. And because they could leverage the scale of the cloud and didn't need to build hardware farms, they could take advantage of all the benefits of modern development forks. Things like continuous integration, stimulate machine learning DevOps, and simplify security updates for a wide range of IoT devices was suddenly possible. With the launch of ARM Virtual Hardware, we demonstrate these benefits and made them available to the entire ecosystem, not just a handful of partners. We also believe they could make IoT and embedded development accessible to cloud-native developers, bring millions of new developers into our IoT ecosystem with Matter support. First, because developers wanted scale, we are making available ARM Virtual Hardware for the vast majority of our Cortex-M product line by adding support of 7 of most popular Cortex-M CPUs. ARM Virtual Hardware will immediately support about 80 billion devices that our ecosystem has already deployed. Software developers can immediately begin to develop, test, and verify their software across all these devices without having to deal with all that hardware. Next on, the tooling side, we are actively working across the ecosystem to integrate ARM Virtual Hardware directly into a broad set of services and tools. This includes everything from custom runners with GitHub, all the way through to ML developed with partners like Quasar and Edge Impulse. We already even integrate ARM virtual hardware into Kyle MDK, making it a natural part of the development process for traditional embedded development workloads. Instead of selecting a board or into the IDE, select the virtual hardware. We are bringing ARM virtual hardware to where developers already go, making it a natural part of their existing flow. And also, ARM virtual hardware support a wider range of device types. This not only includes virtual hardware targets for these new custom designs and all these M-class products, but also ARM virtual hardware support for third-party devices from our partners, including popular development boards from two of our largest MCU partners, NXP and STMicro. It also includes a virtual Raspberry Pi. Beyond this, the team is actively working to add additional third-party devices from across the ecosystem. By extending ARM virtual hardware to third-party devices, integrating it into popular tools and services, and making our most popular M-class models available, we are vastly expanding our ARM virtual hardware library and enabling software developers to easily scale IoT development and test across billions and billions of diverse devices. So how AVH can be used into Matter? As an example of the slide shows, we can use AVH for Matter CI developments. Developers or engineers can update their code into the code library and debug locally first. Then we're able to move it into CI pipeline with a build, test, and get results from the cloud. Then continue the sequence of develop, debug, then to CI pipeline. Also, with the benefit of large scaling, we can add huge numbers of devices in the cloud and not really require the actual hardware in the lab for doing the test. It can be save tons of money, space, and time for doing a large-scale testing under the AVH. My colleague Sandeep, who has also posted a blog for how to use AVH for Matter CI with a step-by-step guiding. So you can click the link in below or just visit our ARM blog to get more details. ARM virtual hardware is a game changer, so we are massively streaming development and test. It is changing the way software is developed for the IoT and bringing a whole new type of developer into our ecosystem. But there is one more piece of the puzzle. It's not enough to just stimulate how software is developed and tested. We have to enable software leverage and reuse so that developer can focus on innovation, not porting between all that diverse hardware. That is what Project Centauri is about. One of the things we talk about the Project Centauri is Open Synthesis Pack. So OMSys Pack is a common format that can be used within any developer environment to package and deliver software to over 9,500 microcontrollers and 450 boards that have already supported the standards. CMC's PEG continues to see great momentum. Actually, in fact, we have recently added some of the most popular real-time operating systems, just like the FreeRTOS and the Tencent OS, to the list of the software available in CMC's PEG format. We have also begun work on integrating CMC's PEG functionality into the most popular IDEs like VS Code. I am also excited to say that the team is continuing to delivering the Open IoT SDK framework. So Open IoT SDK is a reference code framework which including everything from the voice and the keyword recognition software used as part of our total solution to the new OpenSynthesis CDI software standard. As a quick reminder, OpenSynthesis CDI is a community-driven project hosted in Linaro that defines a common device interface for the Cortex-M systems by defining how common services, things like over-the-air updates, are assessed. We are enabling software reuse and leverage for developers, and the ecosystem is taking notice. In just the last few months, we have 8 of the largest industry players, including silicon partners, cloud service providers, and OEMs already get involved, and the numbers is continue to be increased. We are just getting started with the Project Centauri, but the momentum we are seeing has been truly incredible, and I'm looking forward to it reaching its full potential. Looking at this slide makes more proud of what our team has been achieved in the past months. We now have a vast library to draw from as we build up more and more total solution for IoT. We have 8 additional custom designs, including our fast and the most secure M-class design ever. We've gone from 1 ARM virtual hardware target to 13, including support third-party devices and the billions of devices in the field. And we are making great progress on standard and the reference software with the Project Centauri. Also, we will be including the Matter SDK as third-party middleware into our total solution, which will allow all OEMs to consume TS. So we created TS to focus the ecosystem on innovating around a common platform to the benefit of all OEMs, and this Matter integration is an excellent proof point for this. I think the well-known CSA, which is a Connection Standards Alliances, has been formulated Matter standards and provided the testing and the certification mechanisms to strengthen Matter's influence in various fields. The role played by ARM is based on our various standards and our standards in the IoT. A platform that streamlines and simplify, also accelerate the design and the development process of IoT and Matter based on our standardized security mechanism and the support for the ecosystem. These two group parties are working very closely to make sure we have been fully support the Matter, and also the IoT can continue being developed. So we have invested and evolved our total solution for IoT, offering dramatically more custom design, a broader ARM virtual hardware library, and better software reuse abilities. And we have done it for a very simple reason. The IoT runs on ARM, so we sit at the intersection of hardware and software, and we are uniquely placed to lead the ecosystem as they look to push the boundaries of performance, to streamline software development, and to innovate across billions and billions of devices, which also be perfectly be used into any of major device developments, no matter the SoC, the boards, the devices, or ecosystems. Thank you for all of your listening. Thank you.
Thank you, Alan. Next, please help me to welcome Blade, Staff FAE of ARM, to give us a presentation entitled How to Develop and Secure Products Built with IoT.
Hello everyone, it's nice to meet you. I will present about how to develop a security device built with IoT here. Okay, for the first page, that we will to talk about the importance of the security here. Okay, from our report that we have a report that to interview about the more than 600 people that work with the IoT. They are PM or decision maker here. That we can have more than 96 guys that they were seeing that security is already a very important functions in their product. And have 88 that they are agree that security is their top 3 priority for their product, and have 81 the guys that they seen that in the past 80 years, security already become a priority for their business. So that since the security is very, very important right now for all the fields in the IoT. That you can also know that for IoT that we will connect everything that in the internet. So it's really important that to keep your variable information or your personal information here and to make it not too hacked by the other guys. So security is so important. So if you can security by design, it's a very good idea that you can reduce the cost for everything. But that is not an easy task. So sometimes you may don't have the security expert that can help you to consult for everything. And sometimes you maybe don't know how to build for the security mode, or you need to meet for more than 100 requirements for all the specs in all the countries. And sometimes you may also don't know how to have the sales assessment, that you don't know how to build for something about the rule of trust requirement. So based on this situation, that ARM provide our PSA certificate. PSA is the platform security architecture. On this one, and have our third-party lab and our vendors to promote for this certification. And this certification that we already implement so for many key protocol and many key security specs, like the NIST 8259A, that's the spec that from the US, and something like the EN that's 303, that's 645, that's the spec that from the Europe. Okay, here that we show what our achievements right now. You can find that we already have the more than 130 device or product that already passed for our certificate. And for the SoC and IC vendors, we already have the 75 plus vendors that work with us. And for software platform and OEM, that we already have the 20 plus software platform and more than 25 OEM vendors here that work with us. And PSA certificate is already the most important security certification that in the worldwide right now. Okay, for the PSA security that we provide 10 goals, that's the spiritual of our certification. Now we provide something like the security storage, security boot, security update. That's for firmware update, and all the function is very necessary for the IoT device. We also check about the security life cycle to make sure that your device are all in the security. And we also provide something like the isolation or integration across the isolation. That means we will to check for how you will to check for your security region or your non-security region, and how you to transfer data between it. And we also check about for the anti-rollback, that's to prevent someone to steal your device, steal your information, but roll back your things. And we also check about how to follow trust service. And finally, we will have the unique ID in all your device and check that by attentions here. Okay, so we also provide 4 steps to you to let you know how to implement security in your product. The first one we will analyze. We will analyze all the spec you need. We will check for the threat mode and check for the security you need. After that, we will build this one in the software and firmware that for the architecture. If you have the architecture, we will try to implement architecture in your device, in your product, and make sure this one can work, and based on this to development for your firmware. And finally, we will make your product to have the certification to make sure all your design can meet our security spec. So for our PSA, we have 3 different labels here. Like it's used for different products. For the level 1, it's security principles that we will use this one for all of our device and all of our vendors here. It's about the 50 security questions that you can self-fill in for all of the questions and provide this one and review that by lab and the CB. For the level 2 and level 3, that's majorly used for the SOC. All the IC vendors here that they can follow the level 2 and level 3 spec to check the software act, or sometimes the level 3 will also plus for the physical attack here. And here we also will introduce some of the product for OEM there generally for our PSA certified connection device. First one, when you want to develop for your device, that you can choose something like the IC vendor that they already passed for the PSA. And you can also choose the software platform that you already passed PSA to. That means your hardware, your software are already certified. So that means all devices that you build, you can to trust it. And finally, after you build your product, you can also let your product to pass for our PSA certification. So that means you can also tell your customer that your product is already been certified and that have the security quality that you can make sure. So everyone here, that from the IC vendor, from the software development, that from your OEM, that all guys that can have the benefit from our PSA ecosystems. Okay, that besides the certification, that we will also introduce something that from our software point of view. So the first one is about the functional API certificate. This one is we will have something that for our security function that's in your firmware. That we will provide some functions for crypto, some functions for attachments, and some functions for security storage, and some functions for firmware update. And your OS, your middleware that can just to use this API to meet for your functions. So that can to have the first time to the market and reduce some your RD resource to development for all of this one. Okay, we will also provide our OS like the open source software. That this one will be the trust firmware. In ARM, that we provide this one for our Cortex-N and Cortex-A. It's for trust firmware N and trust firmware A. That for microcontroller or from some application processor. We will provide something like a trust inclusive environment-based system that for everyone. Then we will also have the function that we will support that is called PASIC. PASIC is something the platform application for the security. It's a layer that we can do between the firmware and your hardware. And it can support for the cloud-native application. Now you can control your hardware from cloud directly. So if you have this function that you can symbolize for the security and enable for the probability for all your device. So that means in any platform, in any architecture or any hardware, that you can control that from cloud directly if you implement PASIC. Advantage for this one, and that you can use for all the platforms in the IoT. Okay, so finally that we will introduce something that from our industry alignment. That in the 2022 that we have the alignment with the Amazon Alexa. We also have the alignment for our Matter and something for PASIC that I just introduced. We also implement for the security spec from the IOXT. So all of this one that we just to have to extend for our PSA certification. For the Matter is really important, and we will also show some update here for Matter. The Matter security requirements is already updated in the Matter V1.0 spec. And for all of this requirement, we already mapping that in our PSA certificated a new spec that's level 1 B2.2. And ARM is also work with the Matter, their platform security working group very closely. So if in the future they will have any new spec, we will add that in the PSA directly, and we are seeking for more co-work with the Matter in the future. Okay, so this is the final page. That we will just show you all of our documents or all of our resource for the open source API or anything I already put on our website. So if you are interested for the PSA spec, you can just download that from the psacertificate.org. And if you are interested for something like a PSA open resource, like the API, like the spec here, you can also download that from the ARM website. If you have any question, you can also contact with the ARM local partner manager or FAE. I list my email here, that if you have any question, you can also send me the email. It's very pleasure to have the chance to introduce PSEO to all of you, and hope we have a chance to co-work in the future for the security. Thanks.
Thank you, Blade. Please welcome Mr. Porta, Marketing Manager of MediaTek, to give a presentation entitled Design, Build, and Innovate IoT Products that Unlock the Power of Matter.
Hello everyone, this is Porta from MediaTek. Today, my topic is Design, Build, and Innovate IoT Products that Unlock the Power of Matter. I will share MediaTek Matter solutions with you. My agenda will divide it into two sections. First is MediaTek IoT products for Matter. Second, why Wi-Fi 6 is good for Matter. Let's start with the first section, MediaTek IoT products for Matter. Before Matter, all smart home hub devices work on their own. They don't talk to each other. Amazon, they talk only to their device. Google, same. Also, Samsung only talk to their refrigerator and home appliance. Apple only talk to Apple appliance and all Apple ecosystem. Device can only work with compatible ecosystems independently. After Matter, the protocol actually integrated among all different ecosystems into one common language or one common protocol. That is Matter. MediaTek support status about Matter is that we started from IoT device. For the smart home hub, so-called controller, all the tech giant, Google, Amazon, Apple, Samsung, they have their own software stack. And MediaTek, we start from accessory IoT device. We will work with the tech giant for the interoperability test. In Matter standard 100 issued in October 2022, Filogic 130 SDK 3.0 already support Matter 1.0 version. For the future, we will continue to support Matter 2.0. Filogic 130 architecture. Why it is chosen to support Matter? Because it integrated Wi-Fi 6 and Bluetooth 5, also Hi-Fi 4 DSP with MCU ARM Cortex-M33. It is dual-core architecture combined into a single Filogic 130. So it is easy to take away as a 654-321 as a Filogic 130. Highly integrated IoT IC. Why MediaTek choose Cortex-M33 as our core in Filogic 130? For 3 reasons. Firstly, we like to capture the good opportunity of 30 billion IoT device market. And with next generation industrial standard, that is easy for MediaTek to scale in IoT device with ARM. Also, effective general purpose ARM V8 32 bits processor with ARM trust zone support, we able to deliver the secure, reliable IoT device to the market. In the second section, I like to explain why Wi-Fi 6 is good for Matter. Wi-Fi 6, or so-called Wi-Fi 6 Echo, because it supports 6 GHz band spectrum. So Wi-Fi 6 Echo is suitable to be used in better user experience in demanding environment. There are several new features introduced in Wi-Fi 6, not only for the more bandwidth supported, but also some advanced QAM technology and more spatial streams simultaneously, and also OFDMA technology, which allows more subcarrier to be divided among different devices. Also support downlink multi-user MIMO, especially target wait time for power saving. Those technology actually is good for Matter. Let me explain. OFDMA plus MU MIMO for Matter. If we compare in previous generation, Wi-Fi 4, that time only single user MIMO, which means in one specific time slot, the AP or so-called controller can only support one device at a time. Then evolving into Wi-Fi 5, MU MIMO, multi-user MIMO supported, the AP or the controller is able to support multiple devices simultaneously. Now we go to Wi-Fi 6, support MU MIMO, also OFDMA. That means the AP or controller can serve different devices at the same time. Also, they can divide it different frequency into different subcarriers, flexible for different devices. Therefore, in terms of frequency, it is more flexible and efficient for transmission. Wi-Fi 6 extended range for Matter. In previous generation, for example, Wi-Fi 5, we know IoT device actually located among different places inside a home environment. Wi-Fi 5 device, they don't have such high power to send their response message into controller. So in this case, Wi-Fi 6 is able to connect with controller with the same signal because of the extended range function. Another feature good for IoT Matter is target wait time, which will save power for battery device. Before TWT, target wait time, the device always awake, listen to the message from the controller. Even there is no data to be delivered or exchanged. Therefore, a lot of power has been wasted. With target wait time feature from Wi-Fi 6, the device can be wake up and sleep according to a pre-planned with the controller. Therefore, the wake up can happen according to the plan, which results in power saving. Then they also extended the power battery life, avoid traffic congestion, because all the device, they won't wake up at the same time. How does target wait time works for Matter? I like to divide it into 3 steps. First steps, controller and the IoT device, they agree on a wait time. Once the wait time expired, the controller will send a trigger message to device. Device get the trigger message will be wake up, then start data exchange. Once the data exchange finished, it return to sleep mode. That is the 3 steps in target wait time. Target wait time has several operation modes. First mode is individual mode. Individual mode allows the controller to set different wait time to different devices individually. In this example, you can see controller set up the wait time 1 with device 1, and set up wait time 2 with device 2. And the device 1 and device 2, they can wake up accordingly to the wake up 1 and wake up 2. That is individual mode. The other mode about target wait time is a broadcast mode. The broadcast mode actually asks the device to join a group before they will listen to the same broadcast message. Once the device, they join a group, they will listen to the beacon from the controller with the specific wait time and follow the same wait time. Once the wait time expired, the trigger message sent from the controller, then the device will wake up at the same time accordingly. That is so-called broadcast mode. Easy for controller to manage and also save power for Matter device. Let me summarize Wi-Fi 6 advantage in IoT Matter. Firstly, is about the OFDMA. Compared to previous generation Wi-Fi 5 and Wi-Fi 4, which don't have OFDMA, the connected device is limited. With Wi-Fi 6 in this example, the connected nodes can have up to 40 devices, which would be 4 times better than previous generation. And also, MU-MIMO allows the controller to service different devices at the same time. In Wi-Fi 4, no such feature. Wi-Fi 5 is optional, but Wi-Fi 6 is supported MU-MIMO. Latency, for Wi-Fi 6, it supports more throughput, so the latency will be minimized, less than 40 milliseconds. That compared to previous generation, Wi-Fi 6 has 75% improvement in latency. Configuration band and operation band, 2.4 GHz only for Wi-Fi 4, which will interoperability interference with Bluetooth. In Wi-Fi 5, 5G introduced. In Wi-Fi 6, 2.4 GHz or even 5 GHz supported, even 6 GHz. More clean frequency spectrum. Low power support. In previous Wi-Fi 5, Wi-Fi 4, they only support D10. Wi-Fi 6 supports D10 plus target wait time, which will save more than 50 to 90% power in our test. Also, Wi-Fi 6 supports extended range. Extended range allows a device to be connected with controller for 3 dB more. So the extended range also help for IoT Matter device. More IoT, physiological IoT device documents are available in our official MediaTek website. Also, if you are interested in Wi-Fi 6 or even Wi-Fi 7, we have several white papers to be downloaded from our official website. Welcome to visit MediaTek. Thank you very much.
Thank you, Porta. Now, please welcome a speech entitled Matter 1.0 Technical Overview.
Hello, my name is Rob Alexander, and I am the Principal Product Manager for Matter here at Silicon Labs. I will be presenting a technical overview of Matter. Matter is a brand new open standard for IoT that has a huge amount of support in the industry. First, I will introduce why Matter is needed and talk about the background of how Matter came to be. Next, I will give a brief introduction about the network topology, the scope, and the architecture. After that, I will introduce the key features of Matter. We will talk about what is a Matter fabric and what is multi-admin. Then we will get into some of the details of Matter security, including device attestation. Next, we will go through the full commissioning process to illustrate how Matter securely provisions new devices. And then lastly, we will talk a bit about the data model and the interaction model. Now, let's start with the Matter overview. Today, we have seen a lot of fragmentation in the IoT landscape. Ecosystems have created their own dedicated protocols and works with certification programs. This has caused a number of problems. For consumers, it makes it extremely hard to mix and match the product you want with the preferred ecosystem or mobile app, and it becomes extremely difficult to change that ecosystem once selected. Product developers are forced to pick what ecosystem or ecosystems they support and the integrations they provide. This can lead to multiple SKUs of their otherwise identical products in order to provide connectivity to all the markets they want. This also means gaining expertise in all of those areas and navigating the different rules and requirements that those ecosystems have. Lastly, on the retailer side, disparate ecosystems means that you need multiple experts to procure and manage inventory and help guide consumers to the right products. This is clearly not a situation that will allow IoT market to grow and scale. In order to solve the interoperability issues between ecosystems and devices, a unified standard became necessary. With this, Apple, Google, Amazon, SmartThings, and the Connectivity Standards Alliance worked together to start Project CHIP in late 2019. CHIP is short for Connected Home over IP and was later rebranded to Matter in May of 2021. The standard is being driven by over 220 CSA member companies, including a number of extremely well-known brands. Matter is an application layer protocol and has strived to solve the interoperability between ecosystems. As an open standard, it also has a number of advantages. Matter is not owned by any one company and is maintained by the members of the CSA. Matter can reduce IoT complexities for product developers by giving them a single common protocol to implement. It simplifies the setup and onboarding experience for users. It leverages the Zigbee application definitions to provide a large offering of device type support. Native IP functionality allows connectivity to any IP device locally or in the cloud. Silicon Labs has supported Matter since its inception and is one of the top 3 contributors to the open source Matter GitHub. Let's look at Matter's vision. Matter is a protocol that has simplicity, interoperability, reliability, and security as its goals. For consumers, Matter provides a more consistent setup experience across all devices and makes migrating between ecosystems possible. For developers, they only need to develop once, and the product can be deployed everywhere. For retailers, all certified products have the Matter logo to convey they work together. This will provide a simple purchasing experience and reduce the return rate. And the great news is that the CSA has just announced the release of Matter 1.0 on October 4th, 2022. As a result of this, the Matter specification is now available to the public to download. As part of developing the certification program, Matter had a number of early adopters that went through the extensive testing program and have certified real devices. We should hopefully hear more soon from those device manufacturers. Any new manufacturers that want to build and certify a Matter product can now do so at a number of the CSA authorized test labs. Let's look now at the Matter components. Matter, first and foremost, is an application layer built on top of the TCP/IP protocol to ensure that device-to-device functionality is discoverable and behaves consistently across device manufacturers. Matter defines its own application layer security utilizing public key cryptography with certificates and includes device attestation to ensure the authenticity of devices that communicate together. We will go into Matter security in more detail later, but this security layer does not rely upon the security at the lower layers. Matter has been built with an open source first approach, and the complete reference source code is available on GitHub. You can clone the repo and use the Matter 1.0 branch for creating sample applications across a number of different platforms. The software has been extensively tested to ensure that it will be compliant with the CSA's Matter certification program. Matter's common protocol allows more devices like smartphones and smart speakers to communicate with extremely small embedded devices such as light bulbs and sensors. And because Matter devices are using IP technology, they can choose to connect directly to the cloud for enabling functionality beyond the local Matter network. Matter's hardware requirements are low and can be implemented on a number of system-on-a-chip platforms, as shown in the Matter GitHub today. The stack needs less than 192 kilobytes of RAM and less than 1 megabyte of flash for Matter end devices. Here's an example of the Matter network topology. Matter focuses on Ethernet, Wi-Fi, and Thread as the operational connectivity mechanisms. All three technologies natively support IP, and Matter works at the application layer on top of the IP layer. Devices based on different technologies can be commissioned into the same Matter network and communicate with each other. Matter has created a well-defined commissioning scheme common to all devices. For devices with limited interfaces, this makes use of Bluetooth and QR codes to provide an extremely easy setup experience. Matter Thread devices, which are great for low-energy applications, can communicate with Wi-Fi devices through the Thread border router. For non-IP devices, it's still possible to connect to a Matter network. For instance, Zigbee or Z-Wave devices can be connected to the Matter network through a Matter bridge, which is also part of the Matter 1.0 specification. Matter 1.0 supports a number of different device types. These devices have all had multiple vendors implement them to help ensure device interoperability. For lighting and electrical devices, we have simple on-off, bulbs, color bulbs, switches, and plugs. For HVAC controls, we have thermostats, heating, cooling units, and fans. For sensors, we have contact, light, occupancy, temperature, pressure, flow, humidity, and on-off. For access control, we have door locks and shades. For TVs, there are media players and casting devices. For pumps, we have pumps and pump controllers. And lastly, Matter supports controllers and bridges, which includes smart assistants, mobile phones, and bridge devices to other protocols. Future versions of Matter can extend the set of devices that are officially supported as well. Now, let's take a look at the key features of Matter. We will talk about our Matter fabric, multi-admin support, security, commissioning, the data model, and the interaction model. Unlike some other IoT technologies, the communication of Matter could happen within a single wireless technology or across different wired or wireless IP technologies. For example, a Matter device based on the Thread wireless protocol could communicate with another Matter device based on the Wi-Fi protocol. Matter's network of devices are called a fabric. A fabric is defined as a collection of Matter devices which share the same trusted root. In practice, a fabric could represent a single ecosystem. The Matter fabric can live on the same IP network as other non-Matter devices in your home, and even alongside different Matter fabrics. Each fabric is identified by a fabric ID, which is a 64-bit number. Every node in the fabric will have a unique node ID in that fabric, and nodes can be commissioned onto multiple fabrics. Matter has standardized a feature known as multi-admin. A Matter device can be commissioned onto multiple fabrics and be managed by different fabric administrators. All devices are required to support at least 5 fabrics. For example, as shown by the picture on the right, the smart speaker A is the administrator of fabric A. It can commission the light onto fabric A, then grant control privileges to smartphone A on fabric A. After that, the smartphone can control the light. The smart speaker B is the administrator of fabric B. It can commission the light into fabric B, then grant control privileges to smart switch on fabric B. After that, the switch can control the light. These privileges are separate for each fabric and can allow users to try new ecosystems or even completely switch over to using a different ecosystem. Now, let's talk about Matter security. Before we get into the details, let's highlight the security principles that were a key part of Matter's design. First, there is no anonymous joining. All Matter devices are required to provide a unique passcode to the commissioner as part of authorizing the new device on the Matter fabric. This ensures that the user has proof of ownership of the device and is not being maliciously commissioned onto a different Matter fabric. Device attestation. Every device is required to have unique device credentials that are authenticated by the manufacturer. The commissioner will read this during commissioning and validate that the device is authentic. Operational credentials. Devices are given unique operational credentials that are separate from Matter's manufacturer credentials. These credentials are managed by the commissioner and are unique across every Matter fabric. Network credentials are given only after device authentication. The Wi-Fi network key or thread master key are not given until the device has established a secure channel and its device's attestation certificate is verified. Open standard and open source software. This means that the Matter standard is open to third parties vetting the claims by examining the standard and auditing the source code. Devices restrict access. Matter devices may not just communicate with any other device on the same Matter fabric. Matter provides mechanisms to install access control lists that are used to delineate what controllers are authorized to control your Matter device. Matter requires all Matter end devices to have a Device Attestation Certificate, or DAC, indicating the device's authenticity. This is unique to every single Matter device that is created. The certificate chain has a 3-level tier. The bottom level is the Product Attestation Authority, or PAA. The PAA will be used to sign a Product Attestation Intermediate, which is the PAI. The PAI will then be used to sign the Device Attestation Certificates. During commissioning, the DAC will be transferred to the commissioner and verified against the Distributed Compliance Ledger, or DCL. It is important to note that there is no single root PAA across all manufacturers. This will greatly reduce the chance of a compromise impacting all Matter devices. All right, now let's get into commissioning. There are 2 main starting points when commissioning a device. First is a case where the device is already on the same IP network as the commissioner, and the second is where the device is not on any network and needs credentials. Option A is the most common use case for rich UI devices like TVs and thermostats. These devices may be put on the user's network regardless of whether a user wants to control them with Matter. The devices have the ability to configure Wi-Fi or Thread network manually through some manufacturer-specific means. It could be an on-screen display and a remote, or a manufacturer-specific mobile app. Option B is the most common for limited UI devices such as smart plugs, bulbs, sensors, shades, and switches. In this case, the devices need to support BLE. Now let's look at the 3 main commissioning flows. Standard commissioning is when an uncommissioned device will automatically boot up and start advertising that it can be commissioned. This is very beneficial for device types like light bulbs and sensors. User-directed is used for device types that still have limited interfaces, but have a desire for restricting commissioning. One of the best examples would be a door lock. Lastly, there is a custom flow that is useful for devices that need manufacturer-specific mechanisms to enable Matter. This allows the device to indicate Matter support to the end user, and through some of the standard Matter mechanisms, guide them to the right way to access the Matter functionality. For example, the thermostat could be on the user's Wi-Fi network and advertise its Matter capability. A Matter Commissioner can recognize this, and reading a URL from the device direct the user to a web page indicating what to do to update the thermostat's firmware. Let's dig deeper into the commissioning flow. There are three main parts. First, we start with establishing the initial security. Step one is we need to have the Matter device enter into commissioning mode. We will focus on standard commissioning and user intent commissioning. The user will perform the requisite steps here to trigger the device to be ready to be commissioned. Regardless of the means to get into commissioning mode, the device will time out this operation after a few minutes and refuse to accept a new commission until it is started again. One of the most typical scenarios for commissioning will be using a mobile phone as the commissioner. The next step is that the commissioner must obtain the Matter passcode from the device. This can be done by scanning the QR code or entering the Matter passcode manually. The next step depends on whether or not the Matter device is already on the user's Wi-Fi or Thread network. If the device is already on the network, it can be discovered using DNS-based service discovery. This might occur, for example, with a TV or thermostat, where the user has already set up the device on their home network and wants to just add it to the Matter fabric. If a device is not on a Thread nor Wi-Fi network, then it can make use of BLE to advertise it is ready for commissioning. The mobile phone will scan for Matter BLE beacons and then establish a Bluetooth connection to the device. In both the case of the BLE and a device already on the IP network, the next step is to establish a secure channel using Matter's Password Authenticated Session Establishment, or PACE. Using the Matter passcode, a cryptographic session will be established using SPAKE2+ and the NIST P256 curve. As part of establishing this channel, both sides will securely verify that each other has the device's passcode. The next part is installing the new Matter Fabric security credentials. After the PACE secured connection is established, the commissioner will first need to verify the manufacturer certificate and the device compliance status for the Matter device. As we mentioned before, each Matter device is required to have a unique device certificate. The commissioner, in this example the mobile phone, will read the device certificate through the commissioning channel and verify the device is in possession of the associated private key. Then it can communicate with a remote database to validate the device certificate chain and the compliance status of the device. The remote database is called DCL and is managed by the Connectivity Standards Alliance. Next, the commissioner will install the operational certificate for the device. The device will generate a public-private key pair and create a certificate signing request for its public key. The commissioner creates a new operational certificate with the associated device's public key and returns this to the device. This can be done locally on the commissioner, or it could be done using a secure service in the cloud. Matter allows for both. Along with the operational certificate, the device is given the commissioner's root certificate and an access control list with a set of authorized administrators. Once we install the operational security on the device, we can configure the operational network for the device, if it does not already have this. For Wi-Fi devices, we will configure the SSID and the password. For Thread devices, the commissioner will configure the PAN ID and the Thread master key. Now we have the final steps for commissioning. The device can use the network credentials obtained to join to the operational network of Wi-Fi or Thread. Once on the network, the commissioner will verify that the device can be discovered on the IP network using DNS-based service discovery. At that point, the commissioner will perform a Certificate Authenticated Session Establishment, or CASE, to create a new secure channel with the previously established operational credentials. CASE may also be performed at various other points to re-establish security credentials to the commissioner or to other devices on the network. Then comes the final step, when the commissioner can send the finish message. Commissioning is now complete. Any additional application configuration or operational function can be performed using the Matter application clusters. Let's switch gears to talk about the data model. Matter's data model leverages the Zigbee cluster library and .dot, both developed by the Connectivity Standards Alliance. If you're familiar with Zigbee, then it is easy to understand the Matter data model. In the Matter data model, each logical functional unit is represented by an endpoint. Endpoints are generally associated with a device type. Within the endpoint, there could be multiple clusters supported. Each cluster defines a specific function and includes attributes, commands, and events. Let's show you an example of a lighting product. The lighting product may have an endpoint 1 that represents a dimmable light device type. This endpoint contains two clusters. Cluster 1 can providing on-off functionality and state attributes. Meanwhile, cluster 2 can be the level control cluster for controlling and querying the light's dimming settings. The light product could also have another endpoint for a different device type, such as a temperature sensor. The sensor has its own supported clusters, attributes, and events. The interaction happens between local endpoints and a remote endpoint in a client-server model. Please note that this does not perfectly match Zigbee and was extended for the new functionality needed by Matter. Clusters are based on a client-server model. There are attributes, commands, and events defined in the cluster. Each cluster is an abstract of a function. For example, the on-off cluster can be used to implement the on-off of the light, the on-off of an electric socket, or an on-off of a TV. The level control can be used to implement the level strength adjustment, such as brightness, speed, etc. There could be attributes defined on the client side or the server side, or both. Normally, it is on the server side. Some of the attributes may be fabric scoped. Most of them are security-related attributes. For example, you can connect the door lock to two ecosystems at the same time and use different PIN codes for the two different apps. Client and server can interact with predefined commands. The commands mostly work in a request-response manner. Events are a special command. It's an unsolicited command that are mostly notifications. Matter products may contain one or more Matter device types. Device types encapsulate a logical grouping of different functionality. Their functionality may overlap with other device types. Users can easily understand a device type with many common existing devices, while the Matter protocol can provide specific information to the controllers that need to manipulate clusters across multiple devices. Let's take a look at the example of a color temperature light. The color temperature light has the identified cluster, the groups cluster, the scenes cluster, the on-off cluster, the level control cluster, and the color control cluster. A basic white dimmable bulb would have a similar set of clusters but wouldn't have color control. Meanwhile, a smart plug doesn't have dimming capability using the level control cluster and only has the on-off cluster. However, a Matter controller at a minimum has the ability to manipulate all these device types using the on-off cluster. Matter also provides the possibility of working with non-Matter devices. This is possible through the bridge model. The bridge on the Matter side must have an IP interface and respond to all Matter-related messages on behalf of its devices. To the Matter fabric, it will appear as a single physical device, but through multiple endpoints, all devices operating behind it using the non-Matter protocols can be accessed. The bridge device will have a dual identity to proxy the Matter communications and translate to the non-Matter protocol, and vice versa. Depending on how device types, commands, and attributes are represented by the non-Matter protocol, this may map to one or more endpoints on the Matter side. As we introduced in the previous slides, the device communications happens between two endpoints. These communications are called interactions. An interaction can contain one or more transactions within it. Within a transaction is a set of actions. These actions are messages containing the data or commands from the data model to operate on and are generally pairwise messages of a request and response nature. A read request is sent to read attribute data and is responded to by a report data action. A subscriber request is a request to gain regular updates to an attribute and is answered with a subscribe response action. An invoke request is a request to execute a command on the target and is answered with an invoke response. A timed request indicates another action will take place within a timeout period. A status response is a more generic response message used to answer certain common error codes and in a case sent in response to a timed action request. An action contains a path to the data to operate on. This path is encoded in a series of information blocks, or IBs. The most common one is an attribute path IB. This in turn contains a cluster path IB that contains the cluster ID and either a node ID and endpoint for unicast messages or a group ID for groupcast messages. Lastly, a command path IB contains a command to invoke along with an endpoint and the cluster. Let's see an example to illustrate this. This interaction contains a write, a read, and an invoke transaction. The write transaction has a write request followed by a write response. It then has a read request action followed by a report data action, indicating the values or values of the data read. Lastly, the invoke request indicates the command to invoke and is followed by an invoke response. That concludes the Matter 1.0 technical overview. Thank you very much for taking the time to watch the presentation. I hope you have learned enough to get started with your own Matter development.
Next, please welcome Mr. Cashew Chen, the VP of Marketing of Rafael Micro, to give a presentation titled IoT and Matter Product Design from the Perspective of RFIC Design.
Ladies and gentlemen, I'm Cashew Chen from Rafael Micro. I'd like to introduce IoT and Matter Product Design from the perspective of RFIC design. First of all, I would like to explain the difference between IoT versus ICT. IoT market is a vertical application-oriented market. The application is very diversified. You can see that almost 10 different segments can be classified from the IoT segment. So it's very application-oriented and service-oriented. So it's different from ICT and manufacturing, which is a mass production-oriented industry. So as we know, cloud computing and artificial intelligence will change the rules of the game through the edge computing and design. So the integration of IC design and software versus hardware is very key to the IoT application. For example, the IoT-oriented application and service paradigm, we can see that on the left-hand side, you buy cameras for a household, you spend $1,000 to set up the whole home camera coverage for security, for surveillances. On the other hand, cloud service providers, they will give you all the devices for free, but charge you $30 per month to provide the services. So in case you have some event happen in your household, the cloud device service, they can collect all the information, the images, the videos to help you identify the event. So this is the differences just selling the device versus selling the services. We look at the global IoT market. The overall output value of year 2022 is about $157.9 billion. And in the next 5 years, there will be 22% aggregate growth rate. Among them, the IoT security is a very high priority. And the ratio of the hardware versus software is about 70% to 30%. Software occupies a more important market share of the IoT devices market. And on the region-wise, North America, Europe, and China, they will divide the market into three, about 30 to 35% of each. Then we look at the smart home market. It's growing very fast. In the past 3 years, because of COVID-19, so more and more people start to stay at home and work from home. So the whole market, they start to pay more attention. So if we look at more closely into the smart home market, we can divide almost also 10 different segments for the applications. Examples, applications like smart lighting, smart security, small detectors, battery, mobile charging, door lock, etc. So according to the forecast, the number of smart home devices will reach up to 1.7 billion in the next few years. Among them, we can look at the Google, the Amazon, the Apple, and Samsung. They all create their own systems to enter this market. So smart home market will grow very fast in the next few years. There's no doubt. But how can we catch up these market opportunities? That's what we are going to talk about through this presentation. We also want to mention that due to this new standard Matter, the smart home market will become more booming in the next few years. So we look at IoT wireless communication technologies in a very quick few slides. First of all, IoT wireless communication can be classified by several parameters. First one is by its spectrum, its frequency used. For example, people can use 2.4 giga ISM band, which is more popular and more common in our common life. And second is the sub-gigahertz frequency that can be used. Sub-gigahertz is more popular for more long-range coverage due to its long wavelength characteristic. It can penetrate down to your basement or up to 7 floors of your buildings. The second parameter you can use to look at the IoT technology is the protocol. So for the protocol side, we are talking about Thread, Bluetooth, ZigBee, Z-Wave. Those protocols they can be used in so-called WPAN area. Coverage is about 10 to 100 meters. Second is Wi-Fi technology. That can be used for up to 100 to 1,000 meters. It's more common and most common RF technologies we used in our daily life. The other one is so-called Wi-SAN or cis-low-band LED technologies that cover up to 5 to 10 kilometers. That can be used in smart utility like a smart meter reading used in smart utility industry. And for IoT devices, you can use also 4G or 5G, LTE, Cat-M, those technologies. The coverage can up to 100 kilometers up to several cities. So among them, when we design the IoT devices, we need to consider several key points. We need to select different technologies by your application. First one is that you need to decide which network topology you want to use. Your topology is point-to-point, or is a star, or is a mesh technology. For point-to-point, we are talking about Wi-Fi. For star, we are talking about the Bluetooth. For mesh, we are talking about the Thread, ZigBee, Z-Wave, those type of applications. And second, you also want to consider you want to use licensed band or unlicensed band. For unlicensed band, we are talking about 2.4 giga or sub-gigahertz. That band, you can buy a device, you can operate without paying anything. For licensed band, if you buy a device, you need to get a license from your local operators to get a license to get a phone number or device number. Then you can start to exercise your IoT device. The third one is communication range. So if we look at the smart home application, the communication range is typically maybe 10 to 30 meters. But you also need to consider if you have multi-floor buildings, you want to also use not only the 2.4 giga frequency, you also want to utilize the sub-gigahertz so you can penetrate into your basement and into your high floors. And one of the key parameters is also IoT devices power consumption. If you look at the devices you bought in your house, you can classify into either it's AC powered, you can hook up to the AC source without provide battery. For example, your home router, you can hook up your AC source. So you don't really need to care how much power is consumed by your Wi-Fi technology. On the other hand, if you are use battery-powered devices, for example, your doorbell, your smoke detector, even your smartwatch, your radio, you need to consider how long your battery can sustain. So the power consumption will play a very important role. So overall, you need to consider the installation and operating cost of your IoT devices for your small home, for your IoT network. So on this table, we list 8 most common IoT radio technologies. On the blue side, we are talking about Bluetooth, ZigBee, Z-Wave. They are all so-called short distance technologies, but one is use star, one is use mesh. And the data rate also be different. And for the black part is Wi-Fi and Wi-SAN. we are talking about the distance from 100 meters up to 500 meters up to 1 kilometers. For Wi-Fi, you want to use Wi-Fi to transmit a very high throughput video, audio, data stream. For Wi-Fi, you want to utilize its long distance to collect the utilities from the household, from your residential area. And for the green part, the low power wireless access network, the technology most common is LoRa, is Sigfox. Those technologies are also very popular in some countries. The characteristic tells you that it's long distance up to 5 kilometers, up to 10 kilometers, or even 20 kilometers, but the data rate is very low. So typically, you can also only use those technologies to collect information from your sensors from remote site instead of transmit data to those devices. And for the NB-IoT, for the LTE 5G, you can cover very long range. So overall, you can look at your IoT technologies from those 5 key points. The most important point is that IoT also requires security. So when we consider those radio technologies, you can not only judge from the speed, from the distance, you also need to consider whether it's secured, whether your device can be upgraded remotely through the air. So this is the Wi-Fi and comparison with LoRa, with the NB-IoT. We will not go through very details, but those are long distance technologies you can use for your IoT devices. Next, let's talk about Matter. So we talk about Matter, does matter. So if you have Matter technology, then it doesn't matter which vendors IoT devices you are going to use. So from this graph, you can look at that Matter actually is application level standard. It standardized the commissioning and installation process. But behind Matter, actually, Matter built a security mechanism. So all the Matter devices need to be certified to get a certified ID, so make sure it's secured. And also, when you commission one Matter device to your network, a Matter process will make sure it's authenticated and you get a certificate through the whole system. So you can make sure you can be secured. The device you buy it for your household actually is secure, is certified. So no worry, hacker will get into your home. And second, a Matter is application level standard. So which means that all the standard below Matter is existing standard. So no new devices, no new technologies need to be reinvented. So including Wi-Fi, including Bluetooth, including Thread, that can be used in Matter device. The key point is that Matter is IPv6 oriented standard. So for IoT devices in the future, we believe all devices will be IPv6 capable. So that's also why Matter they didn't support ZigBee. Instead of ZigBee, they support Thread because ZigBee is IPv4 and Thread is IPv6. So in the future, you can also expect Ethernet or even cable modem. Those sources can also support Matter as long as the devices is IPv6 enabled. So there are several benefits Matter can bring to the smart home industry. For the smart home users, the Matter standardize the platform commissioning process. For example, you can buy your devices from multiple vendors, from Apple, from Amazon, from Google, from Samsung, from all other companies. You don't need to worry about their compatibility. So you just buy devices based on your needs to increase the coverage of smart home networking. And behind Matter, Matter will take care of the installation and commissioning and then build on the network through the TCP/IP, through the IPv6, IPv4 network. So users don't need to worry about the interoperability of the different IoT devices. So initially, Matter support Bluetooth and also cover the Wi-Fi and cover the Thread. Cover Wi-Fi because Matter need to support the so-called high throughput data video streaming, those type of applications. So Wi-Fi is most common and most suitable for home networking. And second, before it was ZigBee, now it was Thread, because mesh network can also be used in the smart home market. There are a lot of sensors, detectors already in the market already. So Matter can establish the communication between the Wi-Fi network and the Thread devices. Secondly, Matter break down the barriers of cross-vendor platform. So this is the major differences from the current industry standard. So the user just need to pick up the device and then look at the QR code through your mobile phone, and then the mobile phone will identify the device and then issue the authentication request to the Matter device. And once it was certified, then it will tell the device and your home network router to allow the device to enter your communication network either through Wi-Fi or either through Thread. So everything just in a single push button. So Matter can simplifies the installation process a lot. So family members, they can also use Matters through different mobile phones to control, to manage your home network without any interoperability issues. So third, Matter also speed up the new product release for the industry. Before, different design house, different silicon vendors, we need to worry about the interoperability, the protocol stack to enter into a different ecosystem. But with Matter, now everything is standardized. People talking about the same process, same protocol, talking about the same language, so you can get into the network very easily. So about all Matter members, Arm and Rafael we also play a very key role in promoting this new standard to speed up the new system design from our system SoC release process. So, for example, we look at the Matter new device commissioning process. Say that you have one home network already in place. Smart home network is provided, covered by Wi-Fi or by Thread device. Then today you buy a new video set you want to connect to your home network. Then what you need to do is very simple. Just need to scan the barcode on the video set audio of your devices. Then your smart home application will authenticate through BOE devices with the audio video devices to get this certification and issue a certificate. And then your mobile phone application will say that, okay, this is a certified device. Then you will inform your home router or so-called Porta router to do the network research to looking for the devices to enter its own network. If it's Wi-Fi device, you enter into your home network through the Wi-Fi connectivity. If it's a mesh, it's a Thread device, you enter into the Porta router through the connectivity commissioning process. So everything is in a single step. That would be very much simplify the complicated device commissioning process compared to previous times. So when we talking about the SoC, we also talking about the ARM CPU that actually also solves Matter security requirement. Matter, when we talk about Matter, it's not only application level standard. It also a so-called security standard. So for all the Matter devices, you need to go to certified, to get it certified to make sure it's secured. And for the system design, Matter device need to be authenticated to get certification. So all the ID, all the certificate, even the system code can be protected through the ARM security architecture. So ARM CPU actually solve Matter security requirement, and we also take advantage of ARM MCU to design our SoC, which I will go through in more details in later slides. So we're talking about ARM-based Matter SoC development process for your reference. Before that, I'd like to introduce Rafael Michael. It's an IC design house based in Taiwan. Most of the IC is based in TSMC CMOS process to guarantee its reliability, its quality, as well as its cost-performance ratio. This company is focused more on high-frequency broadband RF design, especially we have very big market share in 8K TV, set-top box, receiver, tuner market. We also specialize in satellite, LMB, and tuner receiver IC design. We represent about 30% of the overall market share. On the other hand, we also have new product line from IoT, from optical communications. For IoT, we are talking about Bluetooth, ZigBee, Thread, and sub-gigahertz, and ISM band 2.4 gigahertz, those kind of RF radio. So Rafael Michael actually integrate different technologies for Matter applications. For example, we integrate HBOE AL2.15.1, that's BLE, and 15.4 6LoWPAN-based Thread technologies into one device. And then these devices can support Matter architecture and to cover the communication protocol, including ZigBee, including Bluetooth, including Thread, and covering the 2.4 GHz ISM band and sub-gigahertz band. The application can be used typically, for example, like the healthcare, like the smart lighting, smart parking, and also smart home, those application area. We also provide complete SDK, HDK for the system design partners to increase their release for time to market. And this is an overview of Rafael Michael low power IFOC platform. So based on this platform, it's separate into two portions. One is the communication RF subsystems. In these subsystems, we have radio, we have the protocol stack, we have the MAC integrated. And also together with the RF subsystem radio, we integrate the ARM MCU architecture and then build in different peripherals, timers, security devices, also external flash zone also ship into this device. The reason we use external flash to be shipped together to combine into one SoC is that we can depend on different IoT applications. We can select different flash size to implement the SoC for different applications. That will make the SoC more competitive, more application oriented. So as RF design is Rafael Michael core technologies, we have specialized radio design to make sure the interferences, the ACI performance, and the output power, the sensitivity is of the best class worldwide. And we also utilize the ARM architecture to hook up to our radio to create this SoC platform. So RT569 is a multi-protocol radio frequency transceiver. It can work with most of the 32-bit MCU to create proprietary or specific applications to fit into different IoT application requirements. This radio on the MAC layer can support like Bluetooth 5.3, Bluetooth LE, ZigBee, and also Z-Wave. And can be used for different IoT applications. And through this architecture, we support a so-called multi-protocol. One of the features is that the PA actually integrated into this device. So it supports up to 10 dBm output power, and the receive sensitivity can up to minus 95 dBm. The data rate can support either 1 mega, 2 mega, and more specifically, it has a proprietary mode, can support up to 4 mega bits per second data rate. And this is a very unique application because in some applications, for example, the mouse application in the gaming for the 8K TV, you will need at least 4 megabits per second throughput. So to make sure your mouse tracking can be sensitive enough to meet the requirement. Next is RT581, the dual band multi-protocol SoC. This is a very unique SoC we designed for the IoT application. It supports actually dual radio. So you can run dual radio concurrently. You can operate the Bluetooth in the 2.4 giga and operate the Thread or ZigBee mesh network to support L2.15.4 in sub-gigahertz radio frequency. And inside, the Mac actually support multi-protocol, so all the modulation actually supported. And then integrated with ARM M3 CPU to provide all the advanced features, including securities for the IoT application. So from RT581, we actually create a Matter-specific SoC, which is customized for IoT application. The flash size is 2 megabytes, which is larger than most of the industry SoC you can see today. Why we need 2 megabytes flash? Because in a Matter application, you will need to consider Matter need to be upgraded through the air, so OT application. So you have better to have a dual image. So if you want to run a dual image IoT devices, and then you will need at least 2 megabytes flash memory to store all your application to make sure your upgrade is secured and efficient. So RT583 is a Matter specialized SoC we just released this year for IoT industry. So in addition to all the silicon we released for IoT, all the silicon actually is backup supported by all the software. So the hardware side is all the silicon. So for the orange part, the yellow part is the protocol stack we supported, including the BLE mesh, BLE, ZigBee, Matter thread protocol stack, and also sub-gigahertz protocol stack. They cover all the security and RTOS. So all the protocol stack actually been certified through ZigBee. So those protocol stack we are certified through ZigBee 3.0, Bluetooth 5.3, low energy, and also passed the Bluetooth mesh certification and also Thread 1.3. So all those protocols can be guaranteed when you port it to your system design. Your system can pass all those required certification very easily through this platform. So this is summary of Rafael Micro complete IoT IC portfolio, including 568, 569. Those RF-only devices can connect, communicate with your specific 32-bit MCU. And this also can include 581, 82S3. Those SoC devices support dual band multi-protocol SoC for different kinds of IoT devices design. So all those devices actually take advantages of using ARM Cortex MCU. So when we design these SoCs, we consider several key points. One of the most consideration is that how efficient this architecture can support our SoC to make sure the throughput, the performance is best of the class. So ARM architecture, not only the hardware side, security structure, but also on the compiler and the tech support. So we experienced that for a typical code base, when we compile through ARM, the package, the code size is 20% less than what we did before in a different architecture. And we also experienced this because of the reduction of the code size. Actually, we can use a smaller memory size, and the MAC protocol will be more efficient through this code base. So that's also actually saved the power consumption of our SoC. So our experience is that through this ARM architecture, we can design one of the most complicated SoC in the industry in actually 16 months. This including all the complicated process for all the testing, all the certifications. So we also take advantages of the ARM migration from M1, M3, M5, even in the future M7. So our SoC can be upgraded together with the roadmap through ARM upgrade. So overall, we believe IoT SoC is the keystone of the system product design. So we recommend system vendors to take the advantages of the new standard, Matter standard, which is application and security-oriented standard, and also take the advantages of new SoC we developed, just released for this market, and to create a new ecosystem. This ecosystem is backed up by all the cloud computing, by all the artificial intelligence, and backed up by all the data analytics, and create new services to this new ecosystem. So we'd like to emphasize the partnership of the ecosystem is important. The relationship and the advantages from the SoC, from the IC design vendors and its SoC product can bring the system vendors a lot of advantage. Most important, the cost and the time to market. So thank you for listening, and that's my presentation for today. Thank you.
Thank you, Cashew. Next, we would like to welcome Mr. Jack Chen, the Director of Global Marketing of D-Link, to give a speech entitled Matter for Smart Home Application.
Hi, I'm Jack from D-Link. Today, I will share with the matter of smart home application with you. Let me take a moment to introduce D-Link. D-Link was founded in 1987. So far, it has been 35 years, focusing on communication network equipment and service. We have more than 121 offices in 57 countries around the world, with a total of 1,800 employees. Our business covers consumer, commercial networks, and carrier business. The following is the outline of what I'm going to share with you today. First of all, let's take a look at the definition of smart home. Then share with you the smart home market trend. Finally, let's take a look at what application solutions are available to build a smart home. Smart home, what it is, how it works, and what are its advantages. Security, comfort, and energy saving are certainly among the main benefits of the smart home. But what is meant by smart home? The smart home is a system that allows you to connect objects, devices, and systems together, allowing them to be managed directly from an app installed on a smartphone, tablet, or smartwatch. With the smart home constituted as with IoT, the smart home then will be finally delivered. Let's take another look at the GfK Smart Report. To what extent does consumer intend to make their home fully smart within the next 2 years? It can be seen that within a year, more than 2% of consumers are willing to step into the smart home. The graph on the right is a continuation of the question on the graph on the left, aiming at the statistics on the distribution of smart devices that consumers already own. The data illustrates home entertainment, smart management, and home care as the top 3 smart home applications. This picture shows the distribution of smart home products in the current consumer electronics market. In addition to the top 3 being smart entertainment, smart energy saving, and home care, the 4th place is the smart home gateway. After reading the report of product distribution, we would like to know what are the most important benefits that smart home solutions could offer you, or what you expect from smart home solution. It's clear from this chart that the ranking number 1 is convenience. Increasing importance one benefit of energy besides convenience. Consider the current economic situation, war, inflation, rising gas and energy price. Next, let's look at the factors that influence consumers to purchase smart home products. Suppose you're planning to buy one or more smart home solutions. Which criteria will affect your choice? Obviously, value for money and privacy are the most influential criteria when planning a purchase. For consumers who already own smart devices, product compatibility and reviews are also critical factors when buying new devices. From the previous sharing, we know that Matter is mainly solving the barriers of various ecosystems. D-Link is in the field of consumer product to face the challenge of consumers on the front line. So we have to understand the consumer's awareness for the ecosystem. We ask the first question, is it clear that a product is suitable for Google Home, Apple HomeKit, or others before purchasing? That is, whether consumers know which platform the product is suitable for. Second question, how important is it to you that all your smart home devices, regardless of brand or operating system, be able to connect to each other across platform? The first answer is very obvious. 43% of consumers can clearly identify which products are suitable for which ecosystem. The second answer is very important. 66% of consumers agree with the importance of cross-platform compatibility. That is one of the future of Matter. Friends here, whether they are selling products or service, hope that consumers will readily press the buy button or putting things into the shopping cart. After buying, they will be faced with installation and use. We asked, how would you prefer to have this done to make your house fully smart within the next 2 years? It can be clearly seen from the picture on the left that nearly half of the consumers want to install and configure it by themselves after buying it back. Among them, consumers over the age of 50 are more willing to purchase and install equipment through a third party than consumers under the age of 49. The right side shows the graph of installation preference for the numbers of products owned by consumers. It can be seen that the number of products owned is directly proportional to the willingness to DIY. It means that, for example, consumers who have more smart home devices are familiar with the installation. They will not choose third party to install them. The ease of installation and friendly interface are more important issues, and Matter can help them here. Continue from the previous slide. If a third-party operator is appointed to install, the picture of the left clearly shows that 48% of consumers are unwilling to spend more on installing or setting up devices. Compared with the people over 35 years old, the youngest group, which means under 34 years old, tends to be unwilling to pay and intend to build a smart home themselves. This conclusion also applies to consumers who have more than 5 smart devices, because they already have experience in using them and have a preliminary understanding of general smart home. Face another consumer group, non-DIY consumer. 52% of consumers are willing to spend extra money in exchange for service. What does it mean? D-Link has telecommunication partners all over the world. For telco operators, a low monthly fee is a better business. We also did an analysis. How much are consumers willing to pay for professionals to install and set up connected smart home service? 29% of consumers with an above average income are more often willing to pay between 51 to 150 euros for setup by a professional. This chart is a continuation of the installation fee from the previous page. Let's break down and see. We want to know which of the following categories of service are consumers interested in and how much are they willing to pay per month. Roughly 1/3 of consumers are interested in and willing to pay for a service fee in the smart energy and the smart home security. The most interesting part is the fourth, a single app for all devices. This is one of the biggest advantages that Matter brings to the entire smart industry: cross-platform integration and easy installation. Share the information we want to know most behind the market report. What is the most important concern for you when buying using a smart home solution? It's not surprising that the first place is the price. It has not changed at all in the previous 3 years. I believe that it will not change too much in the future. The second place is security. As Brad shared, ARM's technology in device authentication and firmware security can gradually solve the doubts of our users. The following items are the friendly interface of the installation, product compatibility, and the product series extension. One thing is quite special is that there is too much wireless interference in the home. Currently, we have no solution to this from product proposals, and we may have to start to do consumer education. From the market report shared so far, we have preliminary conclusions. Energy issues are given considerable attention. Consumers are willing to pay a little more for smart power-related IoT devices. The demand for healthcare IoT is getting higher and higher. The second, nearly 50% of users are unwilling to pay someone to install IoT devices. That said, offering a battery-powered device that installs easily, requires no cords, does not need to be plugged into the wall, would be the biggest opportunity to make money. Price, privacy, and compatibility are the three major considerations for consumers when buying. Let's take a look at the current general smart home. In the figure, various devices and connection methods are simply represented by lines of various colors. Lines of different colors indicate that various ecosystems will need their own hub or gateway, then connect to the internet through the wireless router at home. The biggest pain point for consumers is that they have to set up by using individual apps before they can connect to the internet. It also means that for remote monitoring or control, it's necessary to use many apps to realize this. Think about it. Users must take more money to buy and consider where to place the hubs. It depends on how many power outlets or where they are. Obviously, it makes things complicated. This year, D-Link will start with a smart home router equipped with an ARM Cortex-A53 CPU and M3 SoC, acting as the hub of the smart home solution. In addition to providing a stable and secure network, it's also necessary to allow IoT devices of various protocols on the market to be easily directly connected so that consumers can easily remotely monitor and control the smart device at home. It's also easily achieve the goal of cost saving and energy saving. In addition to smart home routers, smart home devices will be launched in the following 5 solutions, namely energy conservation, water leakage sensing, home monitoring, air detecting, and healthcare. Energy conservation will have a smart plug with power statistics, remote control, and monitor the power supply in the home. Water leakage detection is designed for wooden house. In addition to detecting water leakage, it also has a function of shutting down water. The home monitor solution is a mini IP camera with AI function, with functions such as the vehicle and the person recognition and cloud recording. The air detecting solution includes smoke detection alarm and air quality detection. Smart home care is accomplished by combining cameras, sensors, and smart alarm systems. D-Link, one connection, infinite possibilities. Keep building networks for people. Thank you.
Thank you, Jack. Coming up next is the final session, a detailed introduction to the Matter certification that you can't miss today. Let me turn it over to Mr. Thomas Zhang, the Director of Networking and Business Development of Allion Labs, to give us a speech to introduce the Matter certification process and steps.
Hi everybody, this is Thomas from Allion Labs. Welcome to ARM webinar. Today we'll talk about Matter certification. For the Matter certification challenges and solutions, when you receive a tender or RFQ regarding to the Matter certification, you'll encounter the triple constraints. The first one will be cost. So at the beginning of the project, you don't know how much you need to reserve for the budget to perform the Matter certification. And as for the time, you will encounter that you have a shorter project schedule and you don't have time to prepare for the certification. And so when you submit the product to the testing, you'll encounter the failure and you have to retest again. And now cause the shipping schedule to be delayed and jeopardized. And for the scope, you don't know how many testing that you have to perform or how many documents you have to prepare in advance. There are so many forms and data to prepare, and there are so many engineering efforts that you have to invest early. So we think that in order to overcome all these constraints, there are two solutions that we would like to go over today. The first one will be we have to choose a certified solution. Once you have the certified solution, you can expedite your certification process. And the second one is that you have to be prepared in advance by understanding the process, which we'll go over today, and get assistance from anybody. For ARM-based certified solutions, for the Matter certified products, they are NXP products, which are already certified. As for the Rafael Micro, they are having one product getting the certified for the Matter. As for the MediaTek, they have the FieldLogic A30 with the ARM Cortex A53 and FieldLogic 130 with ARM Cortex M33 getting the Wi-Fi certifications. And as for the thread certification, they have the MG12, MG21, and MG24, which are Cortex M4 and M33. So for all these products, they are already certified with either Matter, Thread, or Wi-Fi. So you can utilize those for your Matter certification to expedite your certifications. Let's go over 9 certification steps for Matter. And as you can see from this slide, there are 9 steps to get your product certified for the Matter. The first step will be get the CSA membership. And the second one is that you have to obtain a vendor ID code. And the third one is that you have to select network transport that you would like to use on the Matter and develop the product. And the number 4 is that you have to get the network transport certification from relevant standards organization. And for number 5, you have to choose authorized test provider and submit your device for testing. And for number 6, you have to submit certification application via the certification web tool. And for number 7, you have to get your application reviewed by the CSA certification team. And if you are lucky and you get it approved, you'll receive several documents from the certification team. And for number 9, your product will be listed on the DCL. Let's go over each one. For the step 1, get a CSA membership. As you can see from this slide, there are 4 levels of membership. And in order to get your product certified, it's highly recommended that you get at least adopter level. So that way, by getting this adopter level, you can have your product certified, or you can do the certification by similarity or the product family submission available. And for the associate members, you can only participate in the certification transfer program, which we will not talk about it today. And for the certification step 2, you have to obtain a vendor ID code. So in order to get this vendor ID code, you have to write an email to the certification at csa-iot.org. So that way they can write you an email and give you this vendor ID code, which you will use for the later submission. And for the certification step number 3 and number 4, you have to select a network transport and develop your products. According to the Matter certification and their spec, these are the 4 network transport technologies currently supported by Matter. As you can see, there's Ethernet and Wi-Fi and Thread, and also Bluetooth. So in order to support a Matter, you have to get, if you also support Ethernet, you have to do the IEEE PMA compliance attestation form. And as for the Wi-Fi, you have to have your product certified for Wi-Fi 4 or above. And for the Thread, due to that Thread 1.3 supports Matter, so your product have to support up to 1.3. And as for the Bluetooth, it's used for the Matter commissioning, so you have to do the low energy 4.0 or later. So you have to submit all these attestation forms, which are available for the member access only. So that way, you have to get your membership first, so you can get access to these documents and get it filled out and have your manager sign and send it to the Alliance. For the certification step 5, you have to choose authorized test providers. You can see from the left image. That's an image of the test lab Allion, which I work for. And you can select a test lab using this web link available on this slide. And for the certification step 6, you have to submit a certification application form via the certification web tool. So basically, you can follow this web link and go to this page and submit your application. And you have to submit many documents and data. So in order to do that, you have to have the user guide, which is available with your membership access. For the certification step 7, your application will be reviewed by a CSA certification team. So once you submit it, you will enter to the review queue. So this CSA certification team, they will review your application, and they will take a while. So based on experience, usually it will take 3 to 5 days. And of course, your mileage may vary. So for the certification step 8, if you're lucky, you get approved, you'll receive several emails. The first email you will receive is that they will send you a certification file, which is in PDF form. Then they will list your product on their csa-iot.org website, so you can see your product is listed. And then they will teach you how to use the certified logo with some guidance. And the last one, they will send you another email with the CD block file, which you will write to your firmware So that way your device will be recognized on the Matter network. So for the certification step number 9, you will be a DCO. So basically they will write your device information on this blockchain. So that way in the future, you can also have your product updated using OTA, using this DCL. Let's talk about the Matter test plan. For the test plan, according to the latest 1.0 core and cluster test plans, which was released September 28th of last year, there are over 400 test cases. For the automated test cases, that's 170. For the manual test cases, that's 290. So you can see from the list, there are main test cases. Most are related to the device discovery management, secure channels, those kind of things. For the test plan, all clusters, as you can see, there are over 40 different kind of the test cases. So basically, you will take some time to finish up all these test cases. Let's go over the Q&A. So a lot of people will ask me, so when they would like to do this Matter certification, what should they prepare? So the first question, the answer will be that we have to have the instructor to enter the test mode. So that way we can interact with the devices and set it up to our test environment and test harness so we can perform the test. And for the question number 2, how many devices you have to submit to a test lab for testing? For the answer, that will be 2 devices or more. And for number 3, a lot of people ask how long does it take to take the test? So usually it depends on your PIX files. So if you are able to generate this file, you can provide to a test lab so they can load it to the test environment, test harness, so they can see how many test cases will jump out. Or based on our experience, usually it will take about 15 work days. For question number 4, this is the most common questions we receive from a lot of clients. They would like to ask, for Wi-Fi thread or Ethernet, do we really need to get certified first before applying for this Matter certification? So according to the Matter certification or their policy, yes, you have to achieve the certification from a relevant standards organization before applying the Matter certification, unless your product uses the chip with the transport technology standard certified, as we mentioned on the earlier page. This page will provide several links for you to use. So there are links for the web page and some emails which you can write to get help and also get your vendor IDs. And there are also links that you can get your PIX files. And also there's a GitHub link which you can use for your Matter implementations. Yeah, so thank you for listening to this session. I hope you enjoy and you find this session helpful for your Matter certification needs.
Hello everyone. Today I am going to introduce how we use Google Nest Hub to control FiLogic 130 over Matter. As we know, Matter is a standard protocol for IoT devices, which aims to enable interoperability between different devices and create secure wireless. Therefore, users can easily and safely control IoT devices. About the demo scenario, we are going to show light up LED on reference board over Matter. We prepare the FiLogic 130 as an IoT device, which supports Wi-Fi 6 and Bluetooth 5.2. Also, Google smartphone and Google Nest Hub as an IoT home controller. First, we set up the Wi-Fi connection between smartphone and access point, and then we open Google Home application to pair with the Google Nest Hub. Make sure it can communicate with each other. On FiLogic 130 side, it runs the Matter lighting application example project. User can easily control the LED of device. Touch the Light Up button on the Google Nest Hub screen. Control the brightness and color. User also can use Google Home application on the phone to control the LED. Voice assistant is also supported. OK Google, turn on the best red device. OK Google, change the device color to yellow. OK Google, turn off the best red device. Thanks for watching this video.
Hello everyone, I am Rafael's project manager, Taco. Today I will discuss with you the recently popular IoT application, Matter. Matter is built on 3 network protocols, Ethernet, Wi-Fi, and Thread. These 3 network protocols all support IP version 6. With the IP address system of version 6, the Internet of Things slogan is finally achieved by Matter. Rafael Micro has been dedicated to the RF field of IoT. We developed our RT58X series for 2.4 gigahertz and sub-gigahertz protocol applications. Protocols supported by the RT58X series include Bluetooth Low Energy for Bluetooth Master-Slave, Bluetooth Mesh, and Zigbee applications. This series can also support Zigbee plus Bluetooth and Bluetooth plus 2.4 gigahertz proprietary dynamic multi-protocol applications. For more RT58X SoC information, please visit the Rafael Micro official website. Rafael is very active for Matter's product applications. We developed specific SoC, RT583, for Matter's Thread and Bluetooth product applications. The RT583 has a 2 megabyte flash to support background over-the-air software reception to achieve invisible upgrading. Today, we will demonstrate Matter over Thread, which is part of the Matter ecosystem. Thread is mainly used for low-power battery devices and mesh architectures that can extend the distance of applications. The Thread device connects to a smartphone through a border router. The border router of this demo uses a Raspberry Pi P4 with our RT58X Thread RCP dongle. It forwards the Thread data received via Wi-Fi through a smartphone. There are 2 Matter devices on the right, light and switch applications. A device light is currently not in the Matter network. First, we use the smartphone as our Matter controller. We open Rafael Micro's Matter app to link the Matter device light. By scanning the QR code, we tell the Matter controller which Matter device will do commissioning. We have printed the Matter device QR code on this board so the smartphone can scan it directly. The Matter device must first do commissioning via Bluetooth to join the Matter network. The Bluetooth broadcast sends the Matter device identification code everywhere. The Matter controller uses Bluetooth scanning to know the identification code of a device that wants to join the Matter network. After finding the corresponding identification code, device authentication is performed and the node operational credentials, NOC, are established. After Matter device commissioning succeeds, the NOC is stored in the Matter device. After the credential is established, the Matter device closes the Bluetooth link and uses Thread encrypted dialog for verification. After all verifications are completed, the Matter device has successfully joined the Matter network. The smartphone can be used to directly control functions such as light on-off dimming in the Thread network via the border router. As shown on the smartphone app screen, the Matter device light has successfully joined the Matter network. First, we enter a name for the device. Then we enter the on-off control screen. On, off. Next, the dimming control screen is available. The Matter commissioning process is a little lengthy, so we added a Matter device switch to the Matter network. Now, there are light and switch devices in the Matter network. The light device directly controls the lighting through the smartphone app. You can also use a switch function to control the light on/off through binding. After the binding setting is completed, operate the button on the switchboard to turn off and on the light. The smartphone app can also display the current status of lights in real time in further demonstrations. The Rafael RT583 makes development of Matter device products easy and fast. This is our example of Matter over Thread lighting control products. Thank you.
Thank you all for your participation. We'll see you next time.